Okay, everyone, any
Yes,
doubts in
sir.
refraction? Let's sum it up.
No, sir.
Let's
No
sum it
doubt.
up. In reflection, it is the light which comes from one medium, goes back into the same medium, keeping the angle of incidence and reflection same. The speed of the light also remains the same because it is in the same medium. Talking about refraction, the light will try to go from one medium to another medium. The angle of incidence and angle of refraction may or may not be same. When light passes from one medium to another medium, its speed might change. Okay, it will change. It is because of the change of speed that the light bends. Clear? It is again not called to be as absorption, rather the phenomenon itself is called as refraction whenever it changes the medium. Let's move forward. Now, because of this refraction, we can also feel certain discrepancies, which one is we cannot actually see actual depth of a coin or something which is placed at the bottom of the water in a swimming pool or a puddle or a lake. Rather, we would see it elevated. So this thing is called to be as an apparent depth. Okay, and this is because of the refraction. Now see, the rays from this coin came out like this, then they bent when they came out in the air and came into our eye. Then some of the rays which were bent here came into our eye like this. Now we have a problem in our eye that we can only understand the last direction of the light. We don't have superpowers that we can find out what all bendings the light has undergone. So because this is the last direction, we will trace it back and we will be able to see the coin somewhere over here because we don't have any superpowers. Okay. And because we can see the coin here, we will imagine or we will think that the coin is here and we will miscalculate the depth. And this is why some of the people, miscalculate the swimming pool's depth and they go head on. And it happens that they have to go to hospital next. So whenever you are dealing with a swimming pool, see to it that you put your feet first, check the depth, and then try and act smart and SL world mein rahunga mein, whatever you want to do, that do it later. Otherwise, you will break your head. This has happened with some of like recently 1 year back. It happened with one of my family friend's father. So don't don't do that in excitement because you can misjudge the depth. So it is always better to ask somebody who's attending there, or you just get your feet first and check the depth. Coming to the next important concept, that is of refractive index. What is a refractive index? Refractive index can be termed to be as the bending power of a particular medium. Bending of light, okay? Bending power मतलब लाइट को ये कितना बेंड कर सकता है, उसका जो पावर है उसको हम लोग बोलेंगे रिफ्रैक्टिव इंडेक्स. ओके, ठीक है. अभी now see, you can consider what example should I give you? Let's say there are two roads. Okay, there are two roads. आप लोग स्कूल से निकले हो, you have bunked. Okay, you have ideally done something wrong. और स्कूल के बाहर जाने के दो रास्ते हैं. एक पे वॉचमैन खड़े हैं एंड एक गेट पे मैं खड़ा हूं एंड आई एम लाइक ओके गो बंक, फाइन. तो आप कौन सा गेट से जाओगे?
Sir, can you repeat? I did not understand.
You have bunked the school. Okay,
Okay,
you
sir.
just got an opportunity to bunk a school. Rather
Yes,
not say
sir.
school में possible नहीं होता bunk करना because once you are trapped you cannot go out. Let's say you get into the college, Rutumbara
Yes,
College.
sir.
Wow. And now today all of you all have a plan to go and visit Silver Beach because you're bored. Okay. Now what happens is there are two directions from which you can exit the school or the college. Now there is one college gate wherein a watchman is standing and the other
Okay.
college gate where I am standing. Now because I was your past teacher, you're like, okay sir, please aaj jaane do, bahut pakk raha hai, I'm not well and stuff. You will do and I'll say okay, go, no problem. enjoy your life. So what will happen
Okay.
is, will you choose the gate with the watchman, or will you choose the path which I am there?
Sir, where you are there?
Obviously, some of
Sir,
them,
where you are?
okay, because you know that I won't bend you to go back and sit in the class. Do I have a bending power? I have less bending power. There will be some cases wherein I will figure out that there is something wrong by judging your facial expressions and your body language. And if I find something is fishy, I will not let you go. But if I find you very confident and, okay, it's okay to let you go, I might let you go. That is a possibility. But the watchman definitely will not let you go. So he has a lot more bending power than me. Right?
Okay.
So you can consider that bending power and connect it here to refractive index. वॉचमैन आपकी
Okay,
स्पीड
sir.
भी स्लो कर देगा, बोलेगा चुपचाप हाथ पीछे करके जा, है ना, वो आपकी स्पीड भी स्लो करेगा. Rather I will say run fast, nobody is seeing. Might be that is the case. So the refractive index can be connected this way, that a refractive index is the bending power of a medium. Okay, what is the refractive index? It is a bending power of the medium. You can also say that it is a power of the medium to slow down light. Okay, because in that medium, the light is going to slow down, right? Yes or no?
Yes.
Sir.
So how much can it
Yes,
slow
sir.
down the light? Okay. Now, once you have understood this, just forget. It's okay to remember the formulas. Refractive index is equal to speed of light in air upon speed of light in medium. There's one more formula that we have for refractive index with respect to the angles, which says that refractive index is sin I upon sin r. This one, the sine of the angle between the ray and the in the air and the normal to that of the sine of the angle between the ray and the glass is normal. Okay, it is there in the glass, right? This is in the air, this one is in the glass. So you always take your normal to be as a reference and take your angles from the normal. Okay, Fanil, can you understand? Always take your angles with the normal, with respect to the normal. यहाँ से measure करोगे तो गलत मिल जाएगा. That will be wrong. So always calculate your angles from the normal. Fanil, do you get it? Okay, great. What happens when, sir, if the light is coming 90° to this glass? Will it bend? No. So in that case, your formula or sir, the definition that you gave is wrong. The bending power of the light. So I also told you, it is not just the bending power, it is also the power of the medium to slow down light. Yes, sir, that is true. So what happens in this case is it is not bending because it is a normal incidence, but yes, in this medium, light is slower. Light is going slow. Suppose it is coming at 3 into 10 raised to 8 degree, 3 into 10 raised to 8 meter per second from here in the air. In the glass, it will go at a speed of 2 into 10 raised to 8 meter per second. Do you all get me?
Yes.
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 So even if it is a normal incidence, it is not a bend, it is not completely bending or it is not bending at all. It is still slower in the glass. So how do we show it? You can use wave diagrams or you can say wave fronts to represent that. Let's say this is a wavefront, this is a wavefront, this is a wavefront. It was quite fast. When it enters light, the wavelength will squeeze. This is a proof that it is slower here. Okay, so this is how you can show it using wavefronts. This is a wavefront. This is a wavefront. This is a wavefront. This is also a wavefront. It will remain of the same size. Okay, don't see that I'm making it small, so it is small. It will remain of the same size. Okay, so wavefront squeeze when it goes into the medium like this. I'm just telling you this so that you can understand. Wavefront diagram is not meant for light, okay? It is meant for the ripple tank experiment used for water waves. We have seen it there. Clear? Everyone?
Yes.
Okay. In your in your say IGCSE, we are not representing light by wavefronts. You can do it, yes, but we are not ideally doing it. Now, very important thing before we wind up with the refraction part. Now, there are certain questions wherein the light is coming from the water. Say this is water and there's air, and it is going like this. Okay. So now tell me what will be the incidence angle and what will be the refraction angle. This will be called as the incidence angle and this will be called as the refraction angle. Right? Right? Yes or no? Yes or no? Yes or no?
Yes.
Yes.
Okay.
Yes, sir.
Now, in this cases, what happens is, because this is the first medium and this is the second medium, if you try to do refractive index, you say sin I upon sin R, you are actually finding the refractive index of air with respect to water. Okay? You're trying to find out refractive index of air with respect to water. But in your question, it is given that water has a refractive index of 1.33. What is given is refractive index of water is already given. Refractive index of water is given. What is given? Water. So which formula will you use? This formula wherein you'll be taking sin I upon sin R, or there will be something else. So remember, whenever a refractive index of a medium is given, what is given? Refractive index of a medium is given. Let's say refractive index of medium is refractive index of medium Nm. Then always take sine of theta upon sine of angle alpha. This is my definition. Okay, this is my formula. Don't use it in your IGCSE. I'm giving you this formula only for understanding. Okay, always write down like this for my formula, which is sine theta upon sine alpha, where alpha is the angle of that medium. Where alpha is the angle of the medium. Matlab, yahan pe we have given the refractive index of water. Can you see refractive index of water is given? So I will use the formula. Refractive index of water is equal to sine of the angle in air upon sine of what angle? Angle in water. Okay? Sine of angle in air upon sine of angle in water. But sir, air में तो R है और I है, तो अगर आपने formula में substitute sin R upon sin I हो जाएगा. Yes, that is the case. Because उन्होंने refractive index of water दिया है, because they have given us refractive index of water, always put the angle of that medium in the denominator. Remember this. Forget my formula now. I just gave it to explain. Remember this. What you're going to remember is, if you have any refractive index given of a medium, always put the sign of the angle of that medium in the denominator. Whatever the case. उस medium का angle, उस medium के अंदर का angle should be in the denominator. If you do this, none of your, you can say any of the questions that you solve in the entire light will never go wrong. Okay, remember this concept and please do write it down. Write it down. If refractive index of a medium is given, Okay. So this is the most important point that you will take care of before going to your board paper, mock paper. So put it on some sheet or put it on some sticky note which you're going to refer just right before your boards. This is the golden rule. Follow this and none of your answers will be wrong.
Sir, can you also give an example? for
Yes,
this
yes, I'm
particular-
going to that. I understood that
Okay,
an
sir.
example will really help you out. See, in a normal situation, it's very easy to solve, but the complication starts when you are dealing with total internal reflections. So I think the example is there in the textbook itself at the total internal reflection wala part. I just gave you before so that when you go to that part, you will be much more comfortable. I hope everyone is done writing.
Yes.
Yes.
Anyone left? Rashwadeep, are you confused or are you getting it?
Yes, sir.
Okay. If at all there's any confusion, do let me know. Okay, I'll clear this. Let's move on. Dispersion, refraction, dispersion, any doubts, let me know. Now, this is where the tricky part is. The thing which I've explained will be helpful here. Yes, Arvind, question number 4. Everyone, please solve question number 4. Light travels up through a pond of water of critical. Do you all understand what is critical angle, by the way? I didn't ask if you have doubts in total internal reflection. Do you want me to explain? Please raise your hand if you want me to explain.
Yes.
Okay.
Yes, sir.
Now see, what is critical angle? This only occurs when the light is traveling from a denser medium to rarer medium. From a denser medium to rarer medium, right? Glass is a denser medium, air is a rarer medium. Now, because it is going from a denser medium to rarer medium, obviously it will bend away from the normal. This is a rule. It will bend away from the normal. Now, what happens is if I go on increasing this angle, so this angle will come down, 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 and it will become flat on the surface. Okay, what will happen is because I am going on increasing the angle of incidence, the angle of refraction also increases, and it will come to a point where it will become flat and it will go on the boundary of the two mediums, or it will go through the boundary of two mediums. Now at this juncture, can I say that this is the incidence angle and this is the refraction angle, and the refraction angle has converted to 90 degrees. It is exactly 90 degrees with the normal, right?
Yes, sir.
Yes. So what I can say here is, if I do the math and I would try to find out sine of I to that of sine of I, what is the R in which medium it is? Second medium is air, right? So we are
Yes,
actually finding a refractive index of air with respect to glass. Okay. But what is happening here is that in the questions normally will be given the refractive index, will be given the critical angle, will be given everything, but they will ask us to find the refractive index of glass instead. So if I want to find out refractive index of glass, tell me What is the angle inside the glass? What is the angle inside the glass? This angle.
It is the incident.
Where is the glass? Glass is this medium, okay? And the angle is here. And that angle is either I call it I or I call it as a critical angle C, because critical angle is an angle where if I have my ray coming in at incident angle equal to critical angle, the refraction angle becomes 90 degrees. So this is critical angle, and this is inside glass. So I will have to put it in the denominator.
Denominator.
And what is in the air? Sine of R is equal to 90. What is sine of 90? Can anyone tell me with their calci? What is sine of 90 degrees, please?
So 1.
Yes. Please do it on your calci. Sine of 90.
It is 1.
Anyone with different answer, I will appreciate it. Sine of 90. So remember, whenever you are dealing with your sine, cos, or any such substitution,
Sir,
use your calci in the degree mode. Point number 1. So just check on the very first line, the top line of your calci. Is it showing D or R? Is it showing D or R? Anyone with R?
Sir, D.
Anyone with R? Anyone with
Sir,
R?
R.
Who is that?
Vanshmali.
Vanshmali, please do sine of 90 degree on your calci. Write down sine bracket 90.
Sir, it's showing me 90 only.
So when you're operating your calci in R, you will not get the right answers for degree because it is taking your answers in radians. So you will have to change your setup to degrees. So mode shift setup, something you will have to do, and accordingly you will go to from R to D, and then you will substitute sine 90 to get an answer of 1. Okay, Rashwadeep, what is your calci showing?
Sir, can I do that?
Yes, you will have to do it.
1
But
minute.
in R it's showing 0.89.
Yes, that's the wrong answer. Yes, Rashwadeep, what's your calci showing? Rashwadeep?
Sir, I have changed the. Sir, I have got the another answer.
What is the answer?
Sine is 90 is 1 only.
Yes, Rashwadeep. Did you change? Rashwadeep, what's on your calci? D or R?
I was saying that answer of sine 90, so it will be 1.
Yes, that is right. But on your calci, on the top line, is it showing D or R? Answer. What is
Okay,
it
sir.
showing? What is it showing on your calci? I'm asking you a question, Rashwadeep. Hello?
Yes, sir.
On your calci, please check and tell me, is it showing D or R?
I'm not sure, sir.
Okay, no problem. So when you substitute sine of 90 as 1, you will get this formula. So remember, this is refractive index of glass. When you're using the refractive index of glass, then the angle inside glass will come in the denominator, and that is why the sine C comes in the denominator, even if the light is going from glass to air. This is a question many students ask. Sir, when the first medium is glass and the second medium is air, sir, it should be sine I upon sine R, and it should be sine C upon 90. That is sine 90. So it will be N is equal to sine C. That is a wrong answer. Okay. Yes, Arvind. Yes, Arvind.
So I have done 1 upon sine C, and sir, I am getting the answer as 1.325, and so on.
What angle did you take?
So I have taken 1 and then upon, and So and then sir, it is written that light travels up to a point of critical angle of 49. So I have taken 1 upon sine 49.
So what is the answer you're getting?
So 1.325012993.
What is this refractive index of glass or water?
Sir, it is of glass, sir.
You are in a pond or you are in a glass pond?
Sir, glass.
You are in a pond or you are going and doing your experiment in a glass?
No, sir, in pond.
In pond, what is there? Glass or water?
So, water, sir.
Water. So you are actually finding out refractive index of water, not the
Okay,
glass. Got it? So whichever
Yes, sir.
medium is there, it's that medium's refractive index. So in this case, we'll say, in your case of your question, it is refractive index of water is equal to 1 upon sine of C. So whatever critical angles you get, you will substitute here, and ultimately it will give you the refractive index of water, because in pond it is water. Got it? So in different situations, answer will be different. And remember this, for water, the answer is going to be 1.33 ke aaju baju. For glass, it is going to be equal to 1.5 or iske aaju baju. Remember this. Now you can check. Agar glass aaya to sir 1.5 ke aaju baju mera answer aana chahiye. You can clarify. If you're not getting that answer, that means your answer is wrong. And if you're not getting for water 1.33 k nearby, then your answer is definitely wrong.
Sir, I'm
Oh.
getting 1.325. So, sir,
That's
if
right.
we
That
round
is
off,
right.
we
It's
get
very much near, very much near. So that's fine. Okay. So this is how you will check your answers. So remember this also. If you want to check your answers and be double sure, always remember for glass, the refractive index will come out to be as 1.5. For water, it will be 1.33.
Okay, sir. Thank you, sir.
So why have I put in almost 30-40 minutes of explanation here is because this is the most trickiest and the most difficult part of the entire syllabus. Till now, whatever we have done. Okay. You will lose a lot of marks if you are not clear with this. So I don't want anyone of you all to lose any mark, because this is so simple. If I just give you this logic, always use the denominator of the sign, always use the angle of the medium in the denominator. That's it. Just remember this and you're done. All clear now, everyone?
Okay,
Yes,
sir.
sir.
Yes, sir.
So we'll just solve this question now. So light travels up through a pond of water of critical angle 49 degree. The critical angle is already given.
Yes, sir.
Now, what happens at the surface if the angle of incidence is 30 degree and 60 degree? Now see, is 30 degree and 60 degree critical angles? Are 30 degree
sir.
and 60 degree critical angles? No. So you will have
No,
to use
sir.
the normal formula. But why have they given critical angle, sir? It is actually given to find out the refractive index of water. Okay.
sir.
So what
Yes,
will
sir.
happen is, by using the first formula, that is refractive index of water is equal to 1 upon sine C. This critical angle will help us get the refractive index of water. That you got is 1.325, right?
Yes, sir.
Okay. So now we have refractive index in our hands. Now they're asking what happens to the surface if the angle of incidence is 30 degree. Use the formula. N of water is equal to sine of I upon sine of C. Sorry, sine of R. Now, what is the incident angle now? 30 degree. So let's put 30 degree. N of water is equal to sine of 30 degree upon sine of R. Calculate sine of R, everyone, please. Sine 30 is half upon 1.325. Please solve me and give me an answer for R.
0.37.
Yes, sir. 0.377358444906.
That's a wrong answer.
Perfectly round.
Or if you round it off, you'll get 0.38. If you round it off.
It's a wrong answer. I think you all did not hear what I said, or what did I say. I'm asking you that I want an answer for R. I'm not asking you what is the answer for sine of R.
41.49. Missed where? Sir, 22.02.
I want an answer for R.
Yeah, sir, R. 22.02.
Sir, it's
Sir, I got 2.377.
Okay, tell me
Sir,
what
is my
is.
answer correct? 22.02.
Let me just check. Let's check. So how will we solve? See, these are the steps. Have we already done? We
So
have
your
made
voice went low all of a sudden.
Hello? Is it better now?
Sir, your voice is too low.
Hello, right?
Yes, sir.
Okay.
6.58.
Now see, everyone will keep their mics off. I'll speak and you'll listen. I think there is disturbance coming from your mic.
Erwin.
Yeah. So now what happens is we have got the subject of the formula to be converted to sine of R is equal to, we'll say sine of I, which is 30 degrees, sine of 30 degree divided by refractive index of water. We'll substitute sine of 30 degree, which is 0.5 divided by 1.325. Give me an answer for this, please.
Yeah, I did.
So 0.377.
Okay. Now, whatever answer you get, you will keep it there. And you will say, now sine of R is equal to 0.377. Now remember, now see, over here also you can check your answer. If at all this answer is greater than 1, if at all this answer comes out to be as greater than 1, your answer is wrong. Because sine of any angle can never be greater than 1 or minus 1. It will always lie between 1 and minus 1. Okay, this is a logic whenever you're dealing with sine and cos both. If it is a sine or a cos, and if the answer is greater than 1, then that means it is wrong. Now let's take the inverse. Now what I'm doing is have you studied inverse functions?
Yeah, sir.
Okay, so
Yes,
what we are
sir.
doing is sine is actually a function. Okay, now when it goes on to the other side of the equation, it will convert to sine inverse. So R will be
Yes, sir.
sine inverse of 0.377. Now take this function into your calci. Take this function into your calci, that is sine inverse, and write down 0.377. And
Yes,
tell
sir.
me what is the angle.
22.2.
2.2.
So 22.14.
22.14. So this is the angle with which the light is emerging from the surface. Okay,
Okay, sir.
or on the other
Okay,
side.
sir.
Rather on the other side is what we can say. Okay. Now there is one problem.
Sir,
There's
I
one
got
problem.
22.17.
Yeah, that's fine. That is completely fine. But this answer is wrong. This answer is wrong.
Yes.
This answer is completely wrong. Can anyone tell me why?
Because it's measured in degree.
I showed it in degrees. This answer is again still wrong.
Because we have not specified from where is the refracted ray passes.
Sorry?
Because we have not specified from where is the reflected ray passing.
No,
Then
no,
last-
no, no, no. Let's break the ice. Okay. Now see, why is the formula wrong? That is because our formula ke andar whatever I and R we have taken is wrong. I told you whenever you take refractive index of water, the angle which is inside the water should come in the denominator. Right?
Yes, sir.
And we are saying that the incidence angle we are saying that the incidence angle is 30 degree and the light is traveling up the water pond. So if we are taking the incidence angle in the numerator, that is the wrong answer. We'll have to stick to our concept. If the refractive index of water is given, then the angle inside the water should be in the denominator only, even if they name it as incidence angle. Got it?
Okay, sir.
Got
Yes,
it?
sir.
Everyone, why are we wrong over here?
Yes, sir.
That is because we have substituted this value at the wrong spot. The angle 30 degrees inside the water. So we'll have to put it in the denominator. Otherwise, we'll get a wrong answer. Now, how did I come to know, sir, it is a wrong? How did you come to know? It is because when light travels from water to air, the angle of refraction should be greater than the angle of incidence. So 30 degree hai, so it should be definitely greater than 30 degree. Answer to 22 aaya. It is less. That's wrong, sir. Not possible. So looking at the answers also, you can find out if you are going wrong. Got it? I know it's too much for you. You haven't done it, but it will come by practice. It will come through the practice that, okay, this is wrong. In air, the angle should be greater.
Okay, sir.
Clear? So we have substituted the wrong formula and we have done the formula right maybe, but the substitution is wrong. We should have substituted the sine 30 in the denominator. So let's rework this out.
41.49.
Sine of R upon sine of 30 is what you'll write here. Then you will say sine of R equal to NW multiplied by sine of 30. And then we have NW, that is refractive index of water, to be as 1.325 from the previous equation multiplied by 0.5. Can you tell me what is the answer now? Sine of R is equal to 0.6625. Is it 0.6625?
Yes,
Sir,
sir.
1 minute.
0.66.
Yes, sir. It's 0.6.
Please take the sine inverse now. Sine inverse of 0.6625. Tell me now
So
what is the answer?
41.49.
41.49.
Now tell me, is 41 greater than 30?
Yes, sir.
Yes, sir.
Now your answer is right.
Yes.
Yes, that's right.
Okay, sir.
Got it? So
Yes, sir.
the concept remains, again, supreme concept remains that if you're taking the refractive index of a medium, then the angle inside that medium should come to the denominator. Make it fix in your brain, or else you're losing hell lot of marks. If you're not getting this concept, pray that this doesn't come in your paper. If you're getting it, pray that this comes, so that a lot of people will lose marks and you will gain. So your grades will be higher. Didn't get you, Arvind. You were saying something.
Okay. Fine. I'll clear now. Everyone done?
Yes, sir.
So in this question, we use our formula twice. This is the most trickiest question which we can solve, and it is always connected to total internal reflection. Please solve more questions on this. You all need practice.
Okay, sir.
Fenil. Fenil.
Yes, sir.
So, Fenil, what is your surname pronounced as? Van or Van?
One.
Van. Okay. Are you getting it?
Yes.
Sure?
Yes, sir. Sure.
Okay. So in mocks, you are going to score 100. You have no doubts at all. Like every lecture, super must. Maza aa raha hai, sir. है ना? You don't have doubts at all. That means now you're going to get 100. Everyone, please pay attention. Okay? Fenil, I'm waiting.
Yes, sir.
Should I clear?
Sir.
Yes, sir.
Yes, sir.
Fenil, I want you to be interactive, okay? I want your yes sir to come quite often. Whenever I say done, understood, you should have these kind of things should come from your end. Yeah. Should I clear now? Everyone done?
Yes, sir.
Yes, sir.
Okay. So this was the biggest challenge that you'll have to like accept when it comes to light. These are the only part which can be the most trickiest. So we are done with that. And next, lenses is quite easy, I feel. I don't know about y'all, but this is mostly what most people get it quite easily. Do you need any explanation in lenses?
No, sir.
Okay. Now, okay, one question, if you don't have any doubts. Is this situation, say suppose this is a lens and this is happening, this is a lens and this is happening, this is a lens and this is happening. Is it called to be as a simple microscope? Simple microscope? Simple microscope? Yes or
sir.
no? Yes or no?
Yes, sir.
Yes or no? Vansh says yes.
Yes,
Who,
yes.
who all are with Vansh? Who all are with Vansh? Raise your hand if you are with Vansh. Vansh says yes.
So I think so it would be a mirror, not a microscope.
Is it a mirror? It is a lens. It's not a mirror.
So I
Mirror
don't
is
know
completely
what-
wrong. It is out of scope. Matlab lens. See, when it is a lens, it cannot be a mirror.
Okay, sir.
Okay. It is like, you know, what you're doing is instead of glasses, you are wearing mirrors. Will you be able to see anything behind?
No, sir.
Not possible. So it is a lens. Yes, it is a lens. It is not a mirror. It is a lens. But my question to you all is it a simple microscope? One says very
Yes, sir.
confidently, it is yes. Yes, sir, it's a lens. Sorry, it is a simple microscope. Anyone who supports Vansh? Nobody. Anyone who would like to oppose Vansh? This is not simple microscope. Obviously, you did not support the opposition में तो खड़ा रहना ही पड़ेगा ना. Come on. Raise your hand if you say it is not a simple microscope, sir.
It is not a simple microscope. It's
Okay.
through a lens. It's the virtual image which has been inverted.
That's right, and the explanation is also right. Yes, Dhruv, what is your answer?
Sir, same. It's the virtual image, not the microscopic image.
Okay. Yes, Arvind.
Sir, in the diagram they have written, sir, it is real, and then sir,
Yes,
it is
yes,
written
yes.
that is
Yes, I was coming to that. I was coming to that. This is not a virtual image. It is inverted image. So because he said inverted, I took it as inverted hai, so it is not a simple microscope. But it is a real image. Remember, from lens, the light will pass through and you can go behind and catch it. Have you ever been to a theater?
Yes, sir.
Yes, sir.
Yes, sir.
Everyone? Yes.
Yes, sir.
Yes, sir.
Sir.
Okay. So in theater, what happens is they have this, you can say, projector. Inside that projector, there is a screen or a reel which is going on. From behind, there is a light coming in. This is a lens. It projects onto the screen. Can you go and touch the screen? Yes. You can go
Yes,
and
sir.
touch the screen of your theater. So this kind of an image is a real image. It's not a virtual image. Because it's a lens, in lens on the right side, we get a virtual image. Now, point number 1, point number 2, or point number 3, diagram 1, 2, and 3, all of them are not called to be as a simple microscope. That is because this one is called to be as a simple microscope. Whenever the object is in between the focus and the object O, or the center of the lens, whenever the object is placed in between these 2 points, kahin pe bhi, only that time it can qualify to be called as a simple microscope. Only and only that time it will be called to be as a simple microscope. Keep a note of this. Okay. Otherwise, it is just a lens and it is not used as a simple microscope. If you want to read a newspaper, will you keep your newspaper far away from the lens and you will stay far away and watch the newspaper? Not possible.
No, sir.
Okay, you'll have to keep your newspaper in between the center of the lens and the focus of the lens. That's where you will see the expanded image of those letters that you want to read in the newspaper. Okay, imagine this is A on the newspaper. It will appear expanded only and only when such a situation will come. Okay, and this one is a virtual image. Only in the case of simple microscope is where we will get a virtual image. You cannot go
Yes,
and
sir.
touch this. You cannot go and grab this, or you cannot really take it on a screen. So this one is a virtual image. Okay.
Yes, sir.
In the entire lens, it is only once that you will experience a virtual image, and that is because of the simple microscope concept. And you can see an enlarged image, which is also erect. When you read a newspaper, letter A doesn't appear to be inverted or ulta. It appears as it is. So it is also erect image, or you can say on the same side. And obviously larger. I think we have come to the last chapter that we are going to cover today, and that is electromagnetic radiation. I think, did I give you a short trick to remember all these in the first 2 lectures?
Gamma.
Okay, see, this is how you do it. Now, see, there's one thing that you need to understand while remembering the electromagnetic spectrum. Everyone, electromagnetic spectrum is not sound waves. The entire electromagnetic spectrum is also not entirely light. It is only this particular part wherein it is light. Okay, some of y'all are right. What are y'all writing, Mohak, Dhruv? I don't get it.
Not writing anything.
Okay, you were looking down. Fine. So now see, understand this thing that when you're talking about the electromagnetic spectrum, it is not that the entire spectrum is light. Only this much part is light that we can see. There are parts which are infrared, ultraviolet, X-rays, gamma rays, microwaves, and radio waves. And what you need to also remember is what are they, in which order are they? This is what is to be remembered when it comes to a paper. So there is a shortcut that you can remember like this way. So how to remember? So it is Radio Mirchi, I love you, extra large giraffe. If you don't want to use that large, you can remove extra giraffe. So radio, remember, radio represents radio waves. Mirchi represents microwaves. I represents infrared. Love, L for love represents light. U for ultraviolet. Extra represents X-rays. G for giraffe represents gamma rays. Okay. So the most important point is to remember it in a sequence. So you can remember it like this: Radio Mirchi, I love you, extra giraffe. Khatam. There are many mnemonics, like this much is same, and is particularly there are some differences. X-ray nikalne gai. So nikalne is nothing but gai is G for gamma and X-ray. So you can have different situation. There's one more variant that says Radio Mirchi, I love you, Xmas Golu. Like on Xmas or Christmas, who comes? Santa Claus. Santa Claus is quite hefty. So we call him Golu. So you can do it in many ways. You can see what suits you best. Yes, Arvind, you have doubt? Or you're bored? Your body language says that you're super bored. Yes?
No, sir. No, sir.
Tired.
No, sir. My eyes are hurting a little bit. So
Okay, I
that's why.
got it. See, now these sessions are like, I have to go through the entire, otherwise I won't be able to cover up much of the portion.
Yes,
And we
sir.
have limited time. So I think next time onwards, there will be a easy lecture. I'll give you time to write and, do some stuff in the background. I think majorly we are completed with most of the chapters now.
Yes, sir.
Okay, we'll erase it off. And
Yes,
this
sir.
chapter doesn't have much to explain. It's all self-explanatory. You can just read it out. If you have doubt, you can tell me. Any doubts? It's all about application. Where are they used? How are they used and stuff? And just a bit more of detail over here in this first page, that light travels at the speed of the entire electromagnetic spectrums. All the waves travel at a speed of 3 into 10 raised to 8 meter per second, or 300,000 kilometers per second. They exhibit interference, diffraction, and polarization. They obey wave equation. They carry energy from one place to another and can be absorbed by matter by causing heating and other effects. So these are some of the properties that you need to understand for the entire spectrum. And then it's just that what are their sequences and which thing is used in which place. And that covers your entire chapter. Let's go to the last chapter, sound. Do you want me to go or we should stop here?
That sounds in next class.
Next class. Okay, fine. So we are done from 26 right up to 31. Sorry, 32. Okay. And
Okay,
we are
sir.
just left with sound waves. I
Yes,
think I'll be taking sound waves in the next class. Like for first 15-20 minutes, I'll cover up, or if you don't have doubts, maybe 5-10 minutes. And then we'll immediately jump over to your ATP. Okay.
okay, sir.
And if you have doubts
sir.
in electricity and magnetism, also keep them ready, so
Okay,
that
sir.
we can decide if we want to dedicate a lecture, so I can accommodate that into the next week's planner. If you all don't need it, then I'll just skip that and we'll move forward with my plan.
Okay, sir.
Please make sure you come prepared for that.
Yes, sir.
Okay, sir.
Sure. So we are done here. So I think most of you all have understood the entire portion that has been done for the grade 9. All your doubts have been cleared. We'll be solving past papers also, and we'll be going to ATP also henceforth. So see to it that you work quite well in the background. If I'm sending you something over the weekend, make sure you do it, so that I'll be in a better position to help you out. Okay.
Okay, sir. Okay.
Yes. So I think
Sir,
we'll
we
wind
can
up.
leave.
Yes, I'll wind up here. We'll stop the meeting here. You can leave.
Bye, sir. Thank you, sir.
Bye.
Bye, sir.
Keep solving the lab practice books.
Bye, sir.
Bye,
Bye.
sir.
Bye.
Thank you, sir.
Bye. Bye. Bye.
Sir,
Yes.
sir, I have a doubt in page 131, sir.
Tell me.
So the diagram which they have given, the 3 diagram.
Hmm.
So like not like this diagram, but so in the exam it comes that we have to draw the converging lens.
Yeah.
How to draw the converging lens for this?
Okay. I'll take it in the next class, because I'll
Okay,
have
sir.
to show this to everyone then. If you have a doubt, then obviously everyone will have a doubt.
Okay,
So
sir.
let me just take it in the next class. I'll show you with the compass and how to do it and stuff. Mostly in your papers, the lens is always drawn and shown. So there is no
Okay, sir.
problem of drawing a lens, converging lens or a diverging lens. But
Yes,
still,
sir.
we'll show you a method. If at all it comes out of nowhere, you should be in a
Yes,
position
sir.
how to be able to draw. So I think
Sure,
raise
sure.
this topic in the next class. The very first thing we'll be doing is this thing. Okay.
Sure.
So just
Yes,
make
sir.
a note on your notebook that the first thing that I'm asking sir is to do this for the
Yes,
next
sir.
class. Okay. Yeah.
Yes,
We'll
sir.
start from this point and then we'll go to some.
Okay, sir. Sure.
Yes. Yeah. Anything
Yes,
else?
sir. Bye. No, sir.
Okay. Bye.
Bye, sir. Thank you, sir.
Bye. Bye. Take care.